Hello, my 11th standard and 12th standard warriors. Welcome to the one-shot revision series, the most looked for, the most sought for series for all your revision of concepts as well as problem solving. And today it's all about waves with me, Shreyas, your physics master teacher at Vedantu, going live. Very good. Nice to see all of you, my lovely warriors. Hi, Suchi Baba. Hello, Anthony. Hello, Roshni, Yash, Nikhil, Dhruvendra, Shrikant. Good evening. Hello, Vaishal. And welcome to the one-shot backlog covering series. Although this is for 11th standard, even if you are a dropper student or even if you are a 12th standard student, this session is for you. So let's revise all the concepts. And those of you who do not know me, my name is Shreyas and I'm the physics master teacher at Vedantu, and I have been training kids just like you for more than a decade, and I really hope that you too, just like these students have made me proud over the years, you too are going to make me proud in the years to come. So let's get started with the session. And yep, the way to get started is giving your Guru Dakshina for every day. So go ahead, smash the like button and also hit the subscribe button down there. And hello Muthu, hi Surya, hello Anay. This is a very important chapter, yes. And ISER video, yep, I will be making very special videos in the days to come. Just hold on. There is a lot of work which goes on. Guys, you know what? A secret, when I had to make longer videos like the one I'm making now, it's much easier than the videos which take less time or which is of less duration. Like if I have to make a 1 minute video, trust me, it takes more than an hour, or even if you have to make some 3 or 4 minutes video. So, but I'm ready to do that sacrifice. I want to put in that hard work because I want to give you the quality content and the most amazing pieces of information which probably you can miss out, through your regular channels. Thank you, Vaishal, so much. And Vaishal, thank you for putting up your display picture as the V Enthuse Warrior logo. Even Yash has done that. Good evening, Harsharan. And guess what, guys? Today I had asked some interesting questions in the community tab and I had some interesting responses. The fun moment for me every day is reading all your comments. Trust me on that. I have a great time. Some people are very witty, some people are very humorous, some people are giving the answers, some people give the wrong answers. It's fun to watch all of that. Anyways, this was a poll conducted. You can just put up your things. Okay, we are sharing memes too. Very good. And I had asked a question on which one is correct. Send me a SMS and send me an SMS. So what do you guys think? Okay, Anthony said only JEE. Hello, good night, good evening, good evening. V Narayana. It's not good night, bacha. It's good evening. No matter what, you should always say good evening. Okay, I'll call you Vishu. Okay, yes, I'll call you Vishu. Okay, it is a B. Now you might be wondering, why is it send me an SMS? One guy even said in the comment section, sir, SMS full form is short messaging service and all of that, and S is a consonant, not an vowel sound. But the thing is, S-E-S, it is pronounced with an E. So unlike a scissor starts with a S sound, which is a consonant sound, but when you pronounce SMS, that E, that vowel sound comes first. So that's why you have to say send me an SMS and not send me a SMS. Send me a SMS is wrong, guys. But look at this, 55%. Who are these people? Where do they come from? What do they eat? It's okay. Okay, fine, no problem, guys. I'm not judging you. But the thing is, I'm going to make lots of polls, lots of quizzes just for you. Not just over here, even on my Instagram, I keep posting these quizzes. You can definitely follow me out there. So I want you to learn, and you have to gain lots and lots of bits and pieces of knowledge so that you can improve in your life. That's all I want. Okay, so let's get started with our session. And let's also appreciate our toppers, your seniors who have made us proud last year. And it was not just 1, 2, 3, 4 students, but there are thousands of students who have made us proud. 1,500 plus who qualified JEE Advanced, and there were thousands who have qualified via mains. They have gone into NITs, and very, very large number of students, like you can see over here in the top percentiles. So this year the barrier is going to be even higher, and for you guys who are in 11th standard moving to 12th, for JEE 2023 the barrier will be even higher. and for that we need to work and study really hard. So let's start with the revision, the entire chapter of waves on a string as well as sound waves. So both of them will be covered today. Okay. Yes, Baba, I will be making video on ICERs and IISTs and all of that too. Don't worry. Yep, I'll be making it. Bimashi, you joined in on time. Don't worry. Thank you, Vaishal, so much. Oh, no problem, no problem. Ace Neat, I'll be posting the polls and quizzes right over here too. Don't worry, Vishu, even if you're a NEET aspirant, you can watch these videos. The theory is the same. Yes, very true, Anthony. Don't follow the maximum crowd. The majority, most of them are wrong many number of times. True that. Okay, let's get started. So Jagdeep, for 2022 also you can watch this. It will help you because 11th standard portions are there. So let's talk about the wave equations and all of that first. Okay, just 1 second. Let me get my marker. Okay, so if I have a wave, okay, which is like this. Okay, this is your baseline. Okay, this is your x-axis, and this is basically your y-axis, and the wave is moving with certain speed. Each wave has an equation, and that equation is a function of x as well as time. So basically what I'm trying to say is the y coordinate of any particle on a wave is always a function of the x coordinate and also the time, because as time progresses this wave is going to move ahead. So what exactly is a wave? A wave is nothing but transportation of energy, transportation or making that energy move from one point, which is basically the source, to its destination without the particles moving from their original places from the source to the destination. They can move around that point, they can move left, right, up, down, that's okay. On an average they should maintain their positions, but they are not allowed to go from one point to the other. That's what it means, without the particles moving from the source to the destination. And remember, there are two kinds of waves. One is basically your transverse wave, and then you have your longitudinal wave. So the examples of longitudinal wave is basically your sound, and the examples for transverse wave is light, or even the wave on a string. The wave on a string is a transverse wave. The difference is that the particles move up and down. The motion of the particles is up and down, whereas the energy flows perpendicular to the motion of the particles. That's a transverse wave. Whereas in longitudinal wave, the motion of the particles is parallel to the direction in which the energy is transported. So when I'm talking, the particles of air are moving back and forward, okay, in the direction of the wave propagation. Whereas for a wave on a string, the particles go up and down, whereas the energy goes perpendicular to it. And the generic equation for any wave, although it is a function of x and time, I can always write it as any function of kx plus minus omega t. Any function of this form is a wave equation where this f is going to decide the shape. It's going to decide the shape and the size of that wave. So that function can be a sine function, exponential function, quadratic function. It will decide what is the shape of that wave, how is it looking, what is the size of it. These parameters tell you the direction and the speed. So remember, if it is plus, where is the wave going? If it is plus, where is it going? Come on, try to think about it. Okay. Jagdeep, I'll definitely respond to you, bacha. Please post it in the comment section so that even others can benefit from your doubt. Definitely I'll help you, or wait till the end. I will definitely interact with you too. If it is plus, then it is going in the negative x direction, and if it is minus, then it is going the positive x direction. And the wave speed or the wave velocity, whatever you want to call it, is nothing but omega by k, the coefficient of time upon coefficient of x. That's what the wave velocity is. Okay, fair enough. Now, depending on whether it is a transverse wave or longitudinal wave, you will also have similar equations, in both the cases. But for transverse wave, remember, the particles move up and down, the energy goes like this. So for a sinusoidal wave, if you want to write the equation down, usual wave equation which you're going to deal with is going to look something like this: y is equal to a sine kx plus minus omega t plus phi. This is the general equation for a sinusoidal wave which is transverse in nature. Y represents the vertical displacements or the transverse displacements if the particles are going along the y-axis and the wave is going along the x-axis. Remember that. And for a longitudinal wave, there is no perpendicular motion since the motion is along the wave propagation. So you have displacement is equal to Sm sine kx plus minus omega t plus phi. That's how it is. If you're wondering what this Sm and A are, well, let me tell you what that is. This A is nothing but the amplitude of that particle which is going up and down, how far it is going up and down. This Sm is called as the displacement amplitude, meaning how much is the displacement's maximum value along the motion of the wave. So if the particles of the air are vibrating, they have a maximum limit. That amplitude is called as the displacement amplitude. Is that okay? Yep. I hope this is clear. Whether you do integration sign equal to y, oh, where did I write integration sign? No, this is not integration. This is function, guys. This is f of. This is a function. This is a function. That function gives you the shape and the size. In this situation, it is the sine function. That means the shape will be as per the sine function. If it was exponential, e raised to something, it will be an exponential shape curve. If it is a quadratic, the graph will be parabolic in nature. That's it. Okay? I hope that is clear. All right, Hari Saran. Okay, great. Also, if you're wondering what this omega and k are, you should know it from SHM. We have already spoken about it. That is basically your angular frequency. Angular frequency Omega is nothing but 2 pi f, of course, and your angular wave number is k, which is nothing but 2 pi divided by lambda. Those are your standard values. It's radian per meter. This is radian per second. This is the same omega, which is the angular frequency of the particles performing SHM. See, the particles in the transverse wave are going up and down, they are oscillating, that is their angular frequency, how many radians they cover per second. Similarly, angular wave number is going to be 2 pi by lambda. That's a factor, that's a term which gives me an idea of the wavelength. If it is a long wavelength, then it means you have less radians per meter, and always remember 2 pi radians corresponds to 1 wavelength. So when I have a large wavelength, then since one complete wave represents 2 pi radians, that means per meter I have fewer radians per meter. That's what that K symbolizes. How much angle do I have per unit meter? Alright, now going ahead, I just need to probably change this. This was not speed and energy, this was still your wave equation and all of that. Some more terms which you should also know is that if y is some function of your kx plus minus omega t, this is your wave equation. The particles are moving, the velocity of the particle is derivative of y with respect to time. Standard formula of derivatives which you have learned in 1D kinematics, derivative dx by dt gives you velocity. So if you differentiate that, you get velocity, and I hope you remember that the maximum particle velocity will come out to be a omega, which is similar to that in SHM. If you attended my SHM backlog series or even nurture series, you know this. as a fact that max speed is a omega and acceleration of the particle d square y, the second derivative of y with respect to time, and the max acceleration magnitude is a omega square. Standard things. Okay, I hope you remember that. Okay, having said that, some more things which you should also know is, apart from wave speed being omega by k, it is also frequency into wavelength. So you can extend the formula to f into lambda. That's a standard thing. Also, one more thing about a wave is that whenever you have a wave like this, okay, and you are given 2 points, I don't know, it could be anywhere, you are given 2 points, they are separated by certain distance. These 2 points will be going up and down, they will be oscillating like this. So don't you see that they have a phase difference between them? If the separation between the two particles on a wave is delta x, since the particles don't go up and down simultaneously, the phase difference between this particle and this particle, which are going up and down, they are oscillating, is given by 2 pi by lambda into delta x. This is a standard formula which you should know. Good evening, Blessy. Nice to see you back. Yep, it is also k delta x, definitely. So Aisha, if you are preparing for NEET 2023, when should I start writing mock tests and when should I want to complete my syllabus? I would advise you to complete the syllabus by October, November max for 12th standard, and mock tests you should only write after the completion of syllabus, not before. But yes, you can give part mock tests like 11th standard mock test or a part syllabus mock test, that's fine. Okay. Now, after this, is there anything else that we need to? Yes, there's one more thing which I need to tell you, and especially that's got to do with longitudinal waves. So let me just go back over here. Here you have displacement of amplitude for a longitudinal wave. In a longitudinal wave, when the particles go back and forth, they also create compressions and rarefactions. Compressions are those points where the pressure is slightly higher than the usual pressure. Rarefactions are those points where the pressure is slightly lower than your usual pressures. So there is a pressure variation which also goes. Alternate compressions and rarefactions also travel along with the displacement. So that's why it is also called as a displacement wave and a pressure wave. So a longitudinal wave indirectly is a displacement and a pressure wave. And if you notice the displacement variations, the maximum pressure variation PM is BKSM. B is obviously your bulk modulus. This is your bulk modulus. So that's your solid mechanics. K is your standard K, angular wave number. SM is the same, displacement amplitude. If you are wondering what PM is, this is your pressure amplitude. This is your pressure amplitude. Okay, this is your pressure amplitude. Guys, if you are wondering if I will be getting all the notes, don't worry guys, I'm going to give you all the notes on Telegram like I do always. All my handwritten notes just for your revision, okay? So you're going to get it. Alright, everybody clear till this point? Shall we start doing some questions now? If one is sine, yes, the other one is cos, correct? Nikhil, the displacement and pressure, they both have a phase difference of 90 degrees. They have a phase difference of 90 degrees. So the phase difference between them is 90 degrees. If one is sine, the other is cos. If this is cos, the other is sine. That means when displacement is maximum, pressure is not maximum, pressure is zero. When pressure is maximum, that time displacement is zero. So that's why there is a phase difference of 90 degrees between both of them. Okay, I hope this is clear. Sathwik, if you're in 10th, you should definitely start watching my nurture playlist right from the beginning, lecture 1, 2, 3, 4 till the last lectures have been arranged. Yes, Param, BKSM, that's right. It's like a very easy, convenient way. If you keep saying BKSM, 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 you remember it. It's very easy to remember. It goes with the flow. It's not a tongue twister for sure. Very good, Sathwik. Then you should, if you have watched it, then you should start practicing from HC Verma too. Okay, and I'm so glad that you'll be joining the channel or rather joining the classes regularly from the next year, and you will be entering the 11th standard. It's a really good thing that you have started your early preparation. Hello, Yashika. Can I take 1 year gap after class 12 for the preparation of JEE Mains? Please say, sir, I'm confused. Is there any disadvantage? Okay, Madhulika, I'll tell you. But meanwhile, guys, let me know what is the answer for this. Okay, so if you are going to take a gap for 1 year after 12th standard, Madhulika, the only disadvantage is that you are going to face immense mental stress. That's all. It's a more of a mental stress than anything else. You don't technically, you might lose 1 year, but you don't actually lose 1 year because it has no effect on placements or your future career. In fact, if you take a drop and you're able to get a good college, in fact, it is much better than not taking a drop and going to a normal college and then, not getting the good college tag. So it's up to you. If you can do it this year, please complete it, else take a drop. Okay. Chalo, for problem solving assignments, DC Pandey questions, PYQs enough for max score like 180. So assignments, DC Pandey questions, PYQs 180 plus, yes, plus mock tests. I would also include mock test, Bindu Reddy. Okay, so some of you are saying pitch, some of you are saying quality. Guys, the correct answer is quality. See, when somebody is playing a flute, same song you can play on a flute, same song you can play on a piano, same song you can play on a guitar, same song you can play in a trumpet. All the tunes are same. Agree? But you know which is a trumpet sound, which is a piano sound, which is a guitar sound. You know the different sounds. Why do you know that? Is it because of the pitch? Pitch is the frequency. I'm singing in a very high scale, karke, and I'm singing in a very low scale. So you have that pitch variation. No, it's not because of the pitch. Loudness, no. If you're close by, the loudness is more. If you're far away, the loudness is less. But that does not make any difference in the type of the instrument which is heard. Quality and overtones. Overtones are basically the different frequencies which are multiples of the original frequency, especially in standing waves. No, that's not the reason. It's the quality. Quality decides which frequencies are present in which amount, in how much intensity. Okay, so although the notes are same, what matters is which frequencies are present in how much intensity, and the collective combination gives you the sense of what instrument it is. Like, I might be singing a song and Shimon sir will be also singing a song. But if you're on the headphones and you're not even watching our videos, you know whether it is Shimon sir, whether it is Wazim sir, or whether it is Shreyas sir, even though we both are singing the same song. Okay? Imagine 3 teachers singing Oo Anda Ava. So you know who is singing what, and probably you will not listen to more than 5 seconds. Correct, guys? Yeah. Okay. Because the original song is much better. Alright. Moving on to the next question. Transverse wave is traveling along a string from left to right as shown in the figure. It represents the shape of the string at any given instant. At this instant, among the following, choose the wrong statement. Okay, come on guys, let's see. So Yashika, for preparing laws of motion and gravity, watch my nurture series playlist. It's there, everything in detail. You have time, please watch it. You will get all the concepts clearly. Hello Vardhan, good evening bacha log. So which points have, look at this, A, B, C, D, E, F, G, H. I'll give a hint, don't look at the options whenever you get such kind of questions. In fact, what you should do is figure out where is each point moving and then see which option is wrong, which option is correct. Hello Ariseti Hemant. So let's draw a probably slightly bigger diagram so that I get a nice idea. So I'll just draw the wave like this. Okay, this is point A, like this. This is point B, this is point C, this is point D, this is point E, this is point F, this is point G, and this is H. Now it is clearly mentioned that this is the shape of the wave at that instant and it is traveling from the left side to the right side. That means after a small instant, dt, delta t instant of time, the wave should have shifted forward. So it should look something like this. It should look something like this. I'm just drawing it after delta t instant. I hope your browser resolution is good, or else you will not see the difference. Or else I'll just draw it slightly far away so that you can see it. Okay, so this is how the wave will look like after delta t time, small interval of time. Now observe where is each particle going, you will get the answer. Like for example, point A would have reached over here, correct? It would have reached over here, makes sense? So point A is going down. B point, because it's a transverse wave, would have reached over here. It is also going down. C, although it looks it has gone down, but C is the extreme point. It has just come to rest. At that instant, it is at rest. So at that instant shown, it is obviously at rest. After that, it is going to come down. That's okay. That's a special case. Point D is going to go up, and E is also going to go up. F is also going to go up. G is the extreme point of the SHM, the harmonic motion. So even G point is going to be at rest, and H point is going to come down. So now there is only one option which is wrong, I guess. Observe, A and E have minimum velocity, rest all options are correct. D, E, F have upward velocity, perfect. A, B and H have downward velocity. C and G have zero velocity. A and D don't have minimum. In fact, because this is the mean position, A and E. So in a SHM, what happens? This is the rest position. This is also the rest position. At the mean position, the velocity is maximum. So in fact, it should not be minimum. It should have been maximum. Then it would have been correct. Hence the wrong answer. The wrong answer is option D, guys. Very good, Roshni. Excellente. Rajshekar, it's okay, bacha. Even if you are late, watch the lecture. Whatever you have missed, you can watch the part which you have missed later on. Even a live class gets recorded at Vedantu. Okay. Cool. So, for concepts, see, in the crash course light also you have been taught concept, but let's say you face a difficulty in pseudo force. Let's say you watch the lecture or wherever in one shot or whatever, revision class or backlog class, but let's say you still want some additional explanation on pseudo force. Only for pseudo force, watch the detailed class. But let's say constrained motion is clear, then don't watch that, save your time. Only watch those lectures where you have difficulty in Bindu. Okay? Okay. So, where can I check after about 1 year mains coaching in Vedantu for 12th or after 12th? Or you mean the droppers batch? The droppers batch has not yet started, bacha, for the next year. Next year's droppers batch will start after a few months, not now. So there is a wave in a string and it is represented by this equation. The phase difference between two particles separated by 4 centimeters is, come on, this is an easy one. This is an easy one, come on guys, you should be able to do this. So, two particles separated by 4 centimeters distance. I just gave you the concept just some time back that the phase difference formula is nothing but 2 pi by lambda into delta x. Well, 2 pi by lambda is nothing but k. Now, do I know the value of k? Yes. This is omega, that is k. Pi by 4 is the factor which is the coefficient of x. So coefficient of x is always k. So that is nothing but pi by 4. And the points are separated by 4 centimeters. Well, and I think this is also in centimeters. Yes, it is given in centimeters. So therefore, the answer should be pi radian. And do I have it? Yes, Nikhil. Option A is correct. Moving on to the next question. Everybody clear? Very good, Bhimashri. Very good, Nikhil. Moving on. It is possible to distinguish between a transverse and longitudinal wave by studying which property of the wave. Is it interference? Is it diffraction? Is it reflection? Or is it polarization? Come on. This is an easy one. Which property is it? When waves interfere, you can figure out, oh no, this is transverse, oh this is longitudinal. Or is it diffraction? Or is it reflection? Or is it polarization? Okay. Thank you, Tamil Rasi. Okay, Tamil Rasi saying B, Siddharth, perfecto. Is it diffraction? Is it? Which kind of waves can diffract? Light wave is a transverse wave. It can diffract. Even sound gets diffracted through openings. Diffraction is the spreading of light. Definitely it can. Interference, even a transverse wave and a sound wave, both transverse and longitudinal, can interfere. Reflection, even light gets reflected, even sound gets reflected. But polarization, is the only concept which is applicable for transverse wave. Light can be polarized, unpolarized, but sound cannot be polarized, because in polarization you basically eliminate all those pulses or waves which are in a particular direction, which is perpendicular to the direction of the wave. But in a sound or a longitudinal wave, the wave is going in the one direction, the particles are also oscillating in the same direction. So you cannot eliminate that. When you have a slit or when you have a polarizer, that only eliminates or it allows those oscillations which are perpendicular to the direction of the propagation of the wave. So longitudinal waves cannot be polarized, hence option D is correct. Very good. Always for you, Solar, and all you guys. Hello Naveen, welcome aboard. Okay, looks like your name is Nikki. Very good, excellent. Moving on now to speed and energy of sound waves. Let's get ready for speed and energy. First of all, whenever you have a string and let's say it is stretched by some tension T, then whenever you generate a wave, it will travel with certain speed. That wave speed is given by root of T by mu. What is T? T is obviously the tension. T is obviously the tension in that string. Tension in the string. And what is mu, guys? Mu is nothing but mass per unit length. And certain instances you might have to convert it into density. So mu is rho into area. Remember this. Mu is rho, density, kg per meter cube into area, which is meter square gives me kg per meter. This is a standard conversion which you should know. Also, the power of that wave, the rate at which energy has been generated, that average power which you give into the wave is nothing but half mu v a square omega square. What is this A? Obviously the amplitude of that. So a very important thing which you should know is that always power or intensities are directly proportional to the square of the amplitude. So that's why you always have that A square. Keep this in mind. Also, similarly for a longitudinal wave, like imagine you have this as the compression and then there is a rarefaction and again there is compression, okay, and then again there is a rarefaction and so on and so forth. So what you have, this is compression, rarefaction, compression, rarefaction, compression. This is traveling. Then for a sound wave, the velocity in a solid is given by root of Young's modulus by rho. Young's modulus by rho. Similarly, the velocity of sound in a liquid is given by root of bulk modulus by rho, but velocity of sound in a gas is given by root of gamma RT by molecular weight, which is also gamma P by rho. Okay, so this is for gas, this is for liquid, this is for solid, something which you should memorize, you should remember this. And similarly also have the intensity of the sound, and the intensity of the sound, this is your intensity, how intense it is. So intensity of the sound, which is also the power per unit area. The power, how much power is concentrated per unit area is going to give me the intensity. That is given by half pressure amplitude square by rho. This is your pressure amplitude. This is your pressure amplitude. Okay, this is your pressure amplitude. Keep this in mind. Everybody fine? And in case you have forgotten, remember, if you have a source and the sound rays are traveling like this, okay, in all the directions, you will see that if you measure the intensity here and if you measure the intensity here, it will be different because the same sound is now going to be distributed on a larger area. In fact, the intensity is inversely proportional to R square, where R is nothing but the distance from the source. R is the distance. As you go far away, the energy gets distributed on a large area. Keep this in mind. Last thing which you should know over here is something called as the loudness. So loudness of sound, L is given by 10 log I by I naught. this is in decibels. This I naught happens to be, you know, the least intensity of sound. Least intensity of sound which can be heard. Least intensity of sound that can be heard. So this is a logarithmic scale. So when I say loudness is 70 decibels, 80 decibels, 90 decibels, this is the formula which is used. You find the intensity and put it over here. The least intensity will be given to you in the data sheet or in the question, or it will be given in some indirect way, and the loudness can be found out in decibels using this formula. This is mains plus advanced, bacha. Yes, Shanu, we will be, and there is some surprise coming for all of you, for especially all the 11th standard students who are going to enter into 12th standard. We are going to launch a very interesting thing for all of you. Okay. Harsh, I don't think he would have meant it that way. The thing is, you cannot say that, you know, there are a lot of students who crack, who are in 11th standard and probably did not study in 11th standard, and they are still able to crack it in that 1 year. But that does not mean a 10th standard student gets inspired by it and says that, okay, since many students have cracked only in 1 year or even sometimes in 6 months, I will also chill out in 11th standard, and then, you know, I will just work for 1 year and then I'll crack it. So I don't want the 10th standard students to take that message, because that's not correct. That can work only for a few students. Please remember that. So the point is that even if you're in 11th and even if you have a lot of backlogs, that's why I'm doing these series, so that you guys cover up your backlogs. You guys start watching my lectures in the nurture series. We have all made amazing playlists for you, and then cover up your backlogs, and you at least do those important topics, maybe not everything, so that your 12th standard transition happens smoothly. And when those classes are done in your Vedantu Pro or your coaching or on YouTube, so you understand everything properly and you don't feel that, you know, disconnect in that portion. That's all. Okay, so let's see. Anthony saying A. If pressure amplitude, then it is B KSM. Yes, it is. Angular SHM is in board part or JEE. It depends on which board, but if it is CBSE, it should be a part. Second thing, it's a part of JEE Mains, it's a part of JEE Advanced. Guys, there is no syllabus which has been deleted from JEE. Please remember that. If somebody is fooling you, please don't listen to them. There is nothing which has been deleted from JEE Mains. Yes, the JEE Advanced syllabus is slightly less than the JEE Mains, but does not mean, you know, you have to ignore all the topics. Okay, cool. Okay. No, I don't think it will affect Bindu. All right. So in a string obeying Hooke's law, if it is stretched by, I think there are some additional digits over here for some reason. This should have been just 1.44 times its original length, the ratio of the transverse to the speed of sound in the stretched string. Okay. So what's the question? The question is, what is the ratio of the transverse wave upon the ratio of the speed with the, you know, longitudinal wave? So let's start writing down the formulas that we know. The speed of a transverse wave on a string is nothing but root of tension by mass per unit length. Correct? The speed of longitudinal wave in a string, that is a solid. And what did I just give you? For a solid, it is Young's modulus by rho, right? So let's write down the formula over here. It is nothing but Young's modulus by rho. All right, now let's start playing around with this particular thing. So T will come over here, mu will come over here, Young's modulus will come over here, density will come over here. Now the next thing that I will do, I will leave tension as it is. Mu, I can write it as rho into A. I just told you about it in the previous slides. Mu is rho into A. Density into area gives you mass per unit length. And Young's modulus, I can write it as stress by strain. So stress is tension by area, strain is delta x by L, and that rho stands over here as it is. TT goes, area goes. So I think I am just left with, just check this out. Okay, I'm just left with over here, delta x by L goes on the top, density has gone, area has gone, tension has gone. So only del x by L is remaining. Just check this out. Del x by L is remaining. Is that correct? Yep, everyone. Thank you, Gagan, for all the love, bacha, means a lot. Okay, so let's see. Vignesh, I have taught it in the flash series. Please watch my flash series lecture, damping and all of that. Okay, watch it. Now delta x by L, if it is stretched to 1.44 times its original length, that means delta x by L, that delta x is change in length upon original length. So if the original length was 1, okay, that new length will be how much? It is stretched 1.44 times its original length, so that delta x will be 0.44, guys. Okay, I think over here the wording is slightly different. That's why we will get a slightly wrong answer. The wording should have been slightly different, guys. It is stretched or rather it should have been the extension. It is stretched such that the extension is 1.44 times its original length. I think that word was missing over here, so probably that's why that 10 and all those rubbish things have come. So this delta x is supposed to be 1.44 and the original length was 1. That's what the wording should have been actually. Now 1.44, that's the perfect square. 144 12 square, so actually the answer should be 1.2. 1.2 is nothing but 12 divided by 10, which is nothing but 6 divided by 5. So I think the answer should have been D. The wording here was supposedly it is stretched such that the extension is 1.44 times the original length. That's the correction over here. Yes. No, Nandini, it is not. There is no quota like that. Okay, moving on to the next thing. Yep. Okay, let's move on to the next question coming up on your screen. Okay, sir, because I'm part of the pros profession, I have finished my 11th course, so I just wanted to know whether I can be a part of your batch for 12th. Shanu, I'll be doing lots of amazing courses for all the 11th to 12th moving students. Already some of my courses are available for the 11th to 12th moving students who will be a part of 12th standard. But yes, I'll be doing lots and lots of micro courses, lots of specialized courses to boost your rank in the months to come for sure. Here is another question where you have equation of a wave on a string of a linear density this much. Wave equation is given. The question is, if everything is in SI units, what is the tension in the string? Let's see how to do that. Okay. Harsh, go with what your heart says. That's something which you should always go with. It's not about what others say. Everybody has their opinion and they are right in their own opinion. Maybe whatever your teacher is saying is also correct. Whatever your mom and dad are saying is also correct. Whatever you are thinking is also correct. But you should never feel forced in under any circumstance. So when you have that freedom, when you enjoy something, that's when you do it with pleasure and you will have a lot of interest and you will automatically end up scoring. So go with what your heart says. Don't go by what others say. Okay, even if it's bad, even if it is good, always go with what your heart says, bacha. Okay, so let's move ahead and let's try and solve this question. First of all, the equation over here is a wave equation. The coefficient of time is always going to be omega, and also the coefficient of x is always going to be k. And we have been asked what is the tension. Let's think. The linear mass density is given, tension has been asked. So I know one thing, wave speed is root of t by mu. If by some way I can find v, and since I already know the value of mu, I can find the tension. And yes, why not? I know the wave speed. Wave speed is nothing but omega by k. So using these two formulas, I think I can start solving this question. So root of tension by mu. Mu is whatever that 5 grams. Grams is 10 to the power minus 3 per meter, is equal to omega by k. Omega is 450. 450 divided by 9. So that goes 5 times and then 1 0 from here. So therefore t will be equal to 50 square, squaring both sides. It will be 50 square into 5 into 10 to the power minus 3. 50 square is 2500. So I will bring those two zeros here into 5 into 10 to the power minus 3. And 25 5s are 125. And you have 10 raised to minus 1 from here. And therefore it will become 12.5. So 12.5 newtons should be the answer, which is option C, guys. It's a combination of two concepts or subtopics. Definitely it is C. Yes, Bhimashri. Yes, Anthony. Very good. Okay. So, Games Master, it's very simple. You should focus more on JEE, not on school, because JEE helps you with school or board studies. The ratio should be something like, if you study for 6 days for JEE, 1 day should be for your board studies. You will automatically ace it. Alright, Games Master, and please change your logo, bacha. Games Master, change it to the warrior logo like so many others have done it. There's a link which is there in the description box for all the warriors who are, part of this channel and want to pledge and show your love and affection towards all the teachers and all the people even behind the screen. So do that small gesture. Your token of love is very important to all of us. Which batch will I teach? Math Pile, I will let you know, bacha, very soon. Okay, cool. So Harsh, I would to suggest, come study where your heart is. That's all I would say in one line. That's it. Okay, so you choose. You have to convince your parents, and if not, just ping me on my Instagram. Maybe we can connect over the call or something on Instagram. All right, bacha, Harsh. Okay, so this diagram shows a snapshot of a wave which is traveling along a string. There are 4 elements shown, and the question is, which has maximum potential energy? Okay, if you can avoid, Games Master, maintaining the minimum attendance, do that, Games Master. Okay, maintain minimum attendance. All right, thank you, Anthony. Oh my god, Anthony has been converted. Very good, so proud, so happy. All right, so here's the logic. Whenever you have a string and a wave is traveling over it, notice these points have maximum speed, hence maximum kinetic energy. This point, they have maximum kinetic energy. This point is at rest, so in fact the kinetic energy over here is 0, even here the kinetic energy is 0. That's what it is. Next thing which you should know is that when you take a string, these are the 2 points, okay, and when the string gets displaced to something like this, it stretches more from this to this. If you compare both these 2 elements, when the string is making an angle, its stretching increases, so its potential energy increases. In fact, the potential energy of any element is directly dependent on the slope. More the slope, more is the potential energy. Imagine the same element, if it is here, it has very little energy, but as compared to this element, imagine the stretching is so much, because now as compared to this element, this length is more the stretching, more is the elastic potential energy. Make sense? Hence, out of all these elements, which element has the highest slope? If you notice, point D the slope is 0, point C the slope is this much, point A has the highest slope, point B also has 0 slope. Out of C and A, understand, if that C was over here, then it would have even higher slope. So C has slightly lesser slope as compared to the point here, which also has the same magnitude of the slope as that of the point A. So A has the highest slope, highest potential energy, also even the highest kinetic energy. So hence it should be option A, guys. Got it? Very good. Hello, good evening, Nishi. Welcome. Join in, bacha log. Hi, Anam. Anam, oh my god, the moment Anam comes and he gives me that wicked smile, I know what he's going to say. Yes, Anam, I am doing that. Yes. Please don't disclose it to anyone. Let it be a secret between both of us. I am still with the same thing, whatever you told yesterday. Top secret, Anam. Okay. Hello, Kalyani. Welcome back. Long time. Sir, I joined English Vedantu crash course. Today is the... okay. Yes, Hariharan. I will definitely look into it, and just send me an Instagram message, and probably with a screenshot, and definitely I will let you know. Oh my god, Anam, you're a girl. Oh, I'm so sorry, bacha. Okay. So the moment, I don't know how to pronounce your name, Anam. Am I saying it right? Okay. So I get really scared when you come. Okay. Now I'm going to go shopping. Promise. This weekend I'm going to go shopping for sure. All right. So here it comes. The next question on your screen. Okay. So let's see. Consider a 2 meter long string with a mass of 70 grams which is attached, okay, to the string vibrator as illustrated. The tension in the string is this much. When the string vibrator is turned on, it oscillates with a frequency of 60, produces a wave, and amplitude is this much. What is the time average power of that wave? Let's see. How do I find the average power? Is there a formula? Yep, I just gave it to you just some time back right over here. Half mu v a square omega square. So how about just writing the formula and seeing what and all do we know, what and all we don't know. P is equal to half mu v a square omega square. Do I know omega? Yes, if I know frequency, I also know omega. So omega is known. Do I know amplitude? Yes, amplitude is also known, frequency is also known. Okay. Do I know mu? I think so. 70 gram, and it is a 2 meter long string. So 70 grams in 2 meters, mass per unit length is obviously known just from this fact. Speed is not known because tension is known, but I can find speed indirectly. In fact, I can write speed as root of tension by mu, and here I can put a square omega square. Root mu cancels, and I will just have root of mu t, and here I will have a square omega square. Now it's just a matter of substitution. You can do that. Still, I just show you what and all values you will substitute so that you don't make any mistakes. Mu, mass per unit length, 70 grams. So 70 grams, which is 70 into 10 to the power minus 3 kg upon 2 meters. So that's mass per unit length. Into tension, tension is 90. So into 90 into amplitude. Amplitude is 4 centimeters. So 4 into 10 to the power minus 2 whole square. And omega is 60. 60, that's the frequency. So 2 into pi into 60 whole square. Now, I think you can do that. It's not that difficult. So what you need to do is this will become half. This will become 70 by 2, 35. So 35 into 9 into 10 to the power minus 2 into 4 square is 16 into 10 to the power minus 4 into 2 square 4 into 6 square 36. Okay, and here you have pi square, and here also you have 10 square because 60, so that 0 also has to be squared. Now if you're wondering how to solve this big equation, I'll tell you one simple trick. Okay, a simple way to calculate this. First of all, make this pi square approximately pi square. 3.14 square is approximately 10. That will help you with the calculation. Number 2, this is by 2, right? So anyways, this will become just 8. Not just that, this 9 is a perfect square. So root of 9 will just become 3. Root of 10 to the power minus 2 will become 10 to the power minus 1. Root 35 is close to root 36. 35, 36 close by. So root 35 will approximately be equal to 6. Now it becomes an easy calculation, and when you do the calculation, I think you should get 0.2 kilowatts. Okay, options are not there. This is basically integer type question. Yes, JEE Mains plus Advanced have integer type questions. Nishi here after the chemistry crash course. Oh my God, Nishi, thank you, bacha, for all the love. And I'm so happy with all the students who are enrolled in the crash course or Vedantu Pro who attend both the classes. Guys, it means a lot. It shows that, my God, I won't be happy with one. I want both. Even if I take crash course, I'll still watch YouTube classes. And if I watch YouTube classes, still I will take a pro and I will complete everything. Good. Hats off, guys, to your dedication, and hats off, or rather, I'm jealous of your, your facilities and all the resources that you have, because I really did not have so many resources. I wish I had so many resources during my time. Sir, you'll be surprised. I'm an 8th grader preparing for JEE. Oh my God. NM. Very good. Very good. Sir, क्या आपको हिंदी आती है? बिल्कुल बहुत अच्छी आती है सैफू, और कभी हिंदी में भी बात करेंगे, कभी इंस्टाग्राम पे आ जाओ. Definitely we will talk in Hindi, बच्चा. Okay. So 0.2 kilowatts is close to 200 watts. Yes, it is. Finally caught up at 2x. Very good. So we have to study at home by Vedantu sir. I'm asking this because I'm a 10th grade and planning for JEE. Meanwhile, guys, start solving this question. I will answer some of the doubts. There is a person speaking normally at 40 decibels at 1 meter. If the minimum intensity is minimum loudness is 20, then what's the farthest distance you can be to hear the sound clearly? All right, so we have to just study at home by Vedantu. I'm asking this because I'm in 10th and planning for JEE24 plea. Yes, Games Master, I mean, there are a lot of advantages. Number one, you don't have to travel. Number two, you save on money, energy. Very important. More than money, I would say energy. Okay, money can come and go, but energy, if you are exhausted, you cannot study. Number three, distractions. Lot of distractions happen. Number four, watching recordings, watching it again and again, revision. Number five, you also get your, PDF notes and all of that. Number six, you have two teacher model, two teachers teaching at the same time. So many things are there which you cannot get when you actually go outside the house and watch or attend offline classes. See, I have taught in offline classes. Many teachers are there who have not experienced that offline journey, especially the younger ones, but I have been through all the phases of coaching. I have myself undergone coaching, I have taught in small coaching, big coaching, online, YouTube, everything. So I know what and all are the pros and cons. So even if I had to go back, I would prefer online mode of teaching, even learning, everything, right? So it's not just because of the pandemic or anything. Yeah. So BitSat is easier, but the number of questions are too many. Thank you, Anthony, means a lot. Okay. Yeah, same here, Nishi, high five. I didn't even know about it even in my 10th grade. When all my friends were like, come, let's start preparing for JEE. I was like, okay, what is this JEE? What is this entrance? What is AIEEE? Before I didn't even know what is AIEEE, what is NIT. Okay, let's just fill the form. Let's see what do we get. It was like that. We didn't have anything. No strategy. You guys watch so many strategy videos, how to score, how much marks, how many questions to attempt. My goodness, you guys are like really resourceful and a very lucky generation. So nothing, no strategy, nothing. Achha, what are you doing? Achha, how many questions I have to attempt? I don't know. We only have to sit and analyze, guys. Crazy. Use this. Now, since everybody is using it, you should not fall behind. Don't say that, sir didn't do anything, so I will also not watch any strategy videos. That's wrong. When everybody else is doing it, if you don't do it, you will fall behind. Okay, so if this person is talking and the reasonable audibility is 20 decibels, so how do we figure out the distance? Well, who is this guy? Well, this is Pandu. He's shouting something, blah, 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 blah. Okay, so the sound is going to travel like this. And we know the intensity of the sound is inversely proportional to R square. As you go far away, the intensity will go down, the loudness will also go down. So here is my logic. The loudness formula is nothing but 10 log I by I naught. So since I have two loudness given for distance R1 and R2, so let's do one thing. Let's just take the difference of the two loudness. Sir, why are you taking difference? The thing is, I know one fact of logarithms. When you subtract or add two logarithms, it is basically multiplication and division inside the log. So let's just take the difference and see what happens. If I do L1 minus L2, it will be nothing but 10 log I1 by I naught minus 10 log I2 by I naught. Now this will become 10. Now this log A minus log B is log of A by B. So it will be log of I1 by I naught upon I2 by I naught. So this will end up being 10 log I1 by I2. I naught has cancelled, and this is L1 minus L2. Now what is L1 minus L2? L1 is 40, L2 is 20. So this will become 40 minus 20 is equal to 10 logarithm I1 by I2. Wait a minute, I1 by I2, since intensity is inversely proportional to the distances, can I not say this ratio of I1 by I2 is nothing but R2 by R1 whole square? Think about it. I1 by I2, since intensity is inversely proportional to R square, I1 by I2 will be R2 by R1 whole square, correcto? Amazing go? Okay, very good, very good, very good. So now here is the thing, R2 by R1. Okay, R2 I do not know, the new distance, that's something which I don't know. So that is R2, R1 is 1, and this is whole square. So 40 minus 20, that's 20, and this will be 10 log of R2 square, because 1 square is 1. So this 0 cancel. This is log to the base 10. So it will become 10 to the power 2 is equal to R2 square. So naturally, R2 will be equal to 10 meters. And do I have such an option? Yep, I do. Option C should be correct. Correcto. Amazingo. All right, clear. Very good, very good, very good, my warriors. Let's move on to the next question coming up on your screen. Okay. Now, yes, let's move on to reflection and interference. So cool, guys. Look at this. Just in this one short revision class for 11th, 12th, and also the 13th grade, that is the repeaters batch, you are going to revise the entire transverse waves and longitudinal waves. So even if you're joining in late, watch it from now. Whatever you have missed, watch the recorded after the live session is over. Yep, I'll be providing session PDF. Oh my god, thank you Solar for changing your display picture. Means a lot, bacha. OP, thank you Saifu. Thank you, bacha. Let's go to reflection of sound. I remember going to this famous hill station. I don't know whether you heard of this. It's called as Mahabaleshwar. I don't know whether you have heard of Mahabaleshwar. And I was very young, and that's when there was a tour guide or a travel guide, and he was like, this is an echo point. So, there was a large mountain. We were somewhere here. That's me. Okay. And yeah, you talk, the sound gets reflected, and then you are able to hear the reflected sound back after some time, and it again bounces back from this cliff and again comes back, and you keep hearing your sound back and forth. And that was really interesting. And I used to always wonder during that time. I was very young, guys. And then, yes, obviously, now that I have studied for JEE and all of that, I know how it works. But the funny thing is that echo point was also called as lover's point and also suicide point. Crazy, right? Look at the irony. Lover's point and suicide point. Does it mean something? I don't know. What's the hidden meaning of that? You should let me know in the comment section below. All right, so let's look at a reflected wave. So imagine if you have a wave which has a crest and it goes and hits a rigid or a fixed surface, then when it comes back, the reflected wave is exactly inverted. So the reflected wave is inverted. That's what it is. Very good. Okay. Can I do a series session for question solving for April session? Yes, exactly what do you mean by that? Can you please elaborate on that? Next thing, if you have a crest, but this is a free end, and then when it gets reflected, it comes back as a crest only. This is for a free or a open end. That's something which you should know. Yes, I'm going to do mock tests. In fact, I have been doing mock tests, sprint sessions, sprint series. If you have missed it, please watch. The sprint series, all problem solving sessions. All right, Anam. Great. And also remember a few more things over here, especially in interference of sound, is that whenever you have two waves, this is wave of amplitude A1, this is wave of amplitude A2. They both are separated by certain difference delta x, which is also called as their path difference. Meaning, when two people are shouting, their waves might arrive at different times. So there is a lag in the sound or the waves which are arriving. So there is a path difference that creates that decides the type of interference. So when two waves superimpose over each other, so I have to put a plus sign over here, you get something called as the resultant wave. This is the resultant wave. And basically these two are your superimposing waves. Superimposing waves. Then what you will see is that the resultant wave's amplitude completely depends on this amplitude and also the path difference. So to find the resultant wave's amplitude, the first thing you should know is what is the phase difference between them. And the phase difference is obviously standard formula 2 pi by lambda into delta x. The last thing that you need to do is vector addition. Remember in phasor, or in superimposition of SHMs yesterday, and even in my regular series I have told you, when two oscillations are added, you should basically add their phasors. These two waves are also oscillations, but there is a lag. So when you add two waves, you are basically adding two oscillations, and the method to add two oscillations is by phasor addition. Keep this in mind. So hence, all I'm going to do is take amplitude 1, I'm going to take amplitude 2, and both of them are going to have an angle of del phi, and the vector addition, you can use triangle or parallelogram law, whatever you want to. This will give you AR. Obviously, AR will be equal to root of A1 square plus A2 square plus 2A1, A2 cos, angle between them was del phi. This whole thing is under the root. Also, another important formula which you should know, if you square it and you solve it, I have done the derivation in my regular series, okay, the intensity formula. So the intensity of the resultant wave is given by intensity of wave 1 plus intensity of wave 2 plus 2 root of I1, I2 into cos of del phi. So this is a slightly different but similar formula. So notice where the difference is. It's basically, none of them are squares or roots except for root I1, I2. The derivation has been done in my regular classes of nurture playlist. Please check it out. And remember that whenever your del phi is 0, it is said to be a constructive interference, and when del phi is pi radians, it is said to be destructive interference. So when del phi is 0, meaning both the waves are in sync, the crests come with the crest, they add up and give a bigger amplitude. Del phi is pi, meaning when the crest comes, the trough comes for the other wave, they cancel out each other. That's why it is said to be destructive interference. Exactly, vector addition, Nikhil, exactly. Correct too. Okay, so Niran editors, can you do one thing? Can you also watch, because this lecture is also related to the yesterday's class. It's all there in the playlist. I would request you, I would ask you to watch this lecture first. This one, waves on, sorry, where is it? SHM? Yep, watch this class, okay? And if you still need more explanation, please go to playlists and go down, okay? Go down over here, and you see nurture physics playlist. So in this playlist, I have covered everything, okay? Oops, where did it go? Yeah, this one. Okay, cool. So just go down and you will be able to see. Oh, sorry, this is something else. I went to something else, guys. Where is this? Yeah, this one over here. View the full playlist. Right from units and dimensions to waves. I have done it recently. You can see that. So interference reflection. So what's that? Okay. Yes, it is available, Games Master. It is available for 2 years. It is available in all the languages that you would want, either English or in English. Yes, it is available. So here comes the question up on your screen, and let's see if you guys can solve this. There is a string of mass 2.5 kg and it is under a tension of 200 Newton. The length of the stretch string is also given. If a jerk is given on one end, then the disturbance will return to its original state in how much time? Hello Athar, welcome. Hi Varsha. Okay, the session Bhimashri will be around 2 hours. Okay, 1.5 hours to 2 hours. So since we started it at 7 o'clock, somewhere close to 8:30, yep, or max 9. Okay, let's try and solve this question. First of all, it is mentioned that the disturbance returns to its original state. Let me visualize the situation first. This is the string, there is a disturbance, it goes like this, it hits the fixed end. Remember, this side is free, it is mentioned over here, free fixed. So as it goes to this side, it will reflect, and we know what happens when a crest hits the fixed end, it will get inverted. So you will see an inverted bump which is traveling like this. Okay. Then what happens? This will hit the free end, but for a free end, the inversion does not occur. So if it's a crest, it remains a crest. If it's a trough, it remains a trough. So when it rebounds back, it is still going to come back as a trough only. Interesting. Then when this goes here and it hits back, then you will see it will rebound back as a crest because it has to now get inverted. Okay, it will now go like this, and then when it hits here, and then again it comes back over here. Okay, that's how it will be because this is a free end, right? So after the free end, it will just remain as a crest. This is the most interesting thing. You have to analyze what is happening. So if you think carefully, how many number of times it has gone back and forth? 1, okay, from here to here, 2, 3, 4, because after that it returns to its original state. 1, 2, 3, 4. Correct? Correct? No problem, Simran, it's okay. Let's see if it is B or something else. First of all, did you realize it has gone from here, then it came back, then it went like this, then it came like this and came like that. So if you see, it's basically 1, 2, 3, and this together is the fourth one. This together is the fourth one. So we need to know what is the speed of the wave. So let's find the speed of the wave. Speed of the wave is root of tension by mu. Tension is given to be 200 Newton. Mass per unit length is 2.5 divided by the length of the string is 20 meters. So this will become nothing but 4 into 10 to the power 3 upon 2.5, which I can also write it as 4 into 10 to the power 4 by 25, because this is now a perfect square. Root of 4 2, root of 25 5, root of 10 to the power 4 is 10 to the power 2, 10 to the power 2 is 100, 100 by 5 is nothing but 20, so this will be just becoming 40 meters per second. That's the wave speed. Now, how much distance does it travel? The total distance it travels is 4 into the length of the string, which is 20, which is nothing but 80 meters. So hence, the time that it takes to travel, which is distance by speed, correct? Distance by speed. The distance is 80, the speed is 40, hence the answer will be 2 seconds. And is 2 seconds there somewhere? Yes, it is. Option C is correct. Option. Perfecto. Yeah, it is C, it is not B. Okay, so very, very, very interesting question, because you have to analyze how many times it goes back and forth. It goes back and forth 4 times. So 4 lengths have to come over there. All right, moving on to the next question coming up on your screen now. 2 waves having this equation and this equation, the resultant frequency and amplitude remains equal to the amplitude of the superimposing wave. Then what is the phase difference between them? The approach, Anthony, it's simple for the previous one. The wave speed is simple, root of tension by mu, that's standard formula. Wave speed is simple, but here this is the reflection part. When it reflects at the fixed end, it inverts. Reflects at the free end, it remains the same. But this is not the same state as before. It has to come to its original state. That means the crest should be up on the top and it should be going that side. That happens after 4 such, distances that it has traveled. Okay, no problem, Solar. The next chapter I'm planning most likely either gravitation, fluids, something like that. Okay, solids, gravitation, or something maybe on solids, something like that. Okay, cool. So if these are the 2 waves and if the resultant wave also has the same amplitude, then what is the phase difference between them? Let's try and understand. There is a wave, there is another wave, and you add them and you get the same amplitude. How is this even possible, you might think? Guys, it is possible if you look at it the vector way. Whenever you superimpose wave, you have to add their vectors, their phasors. Add it like vectors. You have to add the amplitudes, treating them like vectors. So imagine if I tell you vector A plus vector B is vector C and all 3 are of the same magnitudes, the first thing that should click to your mind is an equilateral triangle. So if one vector is here, the other vector is here, the resultant vector will be here, and this becomes an equilateral triangle. Only then the resultant has the same amplitude as the other 2. Now it becomes simple, because now that you see over here, the angle between the 2 waves is angle between the 2 vectors is 120 degrees. not 60. Don't take this. This is wrong. Whenever you measure the angle between two vectors, you always have to join them tail to tail and only then measure the angle, which is 120. Here, this is the head, this is the tail. That is not the correct definition of measuring the angle. So I think the answer should be 2 pi by 3, option B, correct. Very good, Tahira. Very good, Anthony. Yes, Harsha. I can see all the logos. Very good, Solar, Anthony. So nice, Harsha, to see all your display pictures converted. Okay, cool. A pulse shown over here hits the rigid wall and then reflects from the other free end. After this and this two reflections, how will be the exact shape of it? Let's see how many of you can do this. Interesting question. This is your wave. It gets reflected 2 times. Let's see how many of you can figure out the exact shape of it. It's a very easy question. Draw it. Kushagra, welcome, bacha. Draw it. Trust me, you will be able to do it. Think. Is it A, B, C or D? Can we see the missed classes in crash courses again? Yes, Vicky, you can see all the missed classes. You have to go to the past tab. Past tab. Okay. All right. No, I'm not a Malayali. I'm a Indian bacha. Okay. So, Bhimashri is saying option C. Okay, let's figure it out. Come on, come on, come on, my warriors. All right. Let's figure this out. It's not coming. Oh, I got to know from some of the students that they are not able to see the replays. Don't worry. I'll get it fixed if we are not able to see the replays. Okay. Probably it should be a bug or something, but don't worry. Many other students are able to see it. Maybe there is a small bug. I will get it fixed. Don't worry, bacha. Okay. So let's have a look at this. First, when this wave hits from the fixed end, what will happen is it will come down, but this edge, the flat vertical edge, is going to hit first, so it will reflect back first. So you should get the flat edge which is coming like this, and this slant should come here and it should be like this. That's how the wave will go towards the free end after one reflection. Now again, when this hits over here, remember, if it's a trough, it will come back as a trough, so it has to be down, it can't be up. So obviously B option is wrong, even D option is wrong. Only it has to be down. Now whether it is A or whether it is C, that's something which we will have to look into after analyzing the situation. The flat vertical edge, after reflecting over here, it will come back first. So what you're going to see is the flat edge will come out first and the slanting edge will come after it. So it will look something like this. So is there an option like that? Yes, option A. Option A. Correcto. Very good, Tyra. Greatness of God. Very good. Aspirant J, welcome. Sir, able to see the replays. Very good, Rupali. So like I said, it will be probably a problem with only few students. Don't worry, I will ask the backend operations team to have a look into it again if there are some issues, and it will be fixed. Don't worry, you will be able to see all the replays at any point of time like promised. Definitely. Okay. Okay. Oh, acha, Vicky, if sometimes that comes, right, there is something called as try-alternate replay. I wish I could show that to you right now. I have to again sit and log in. But at the bottom, you will see something called as try-alternate replay. Try that out. It will work. And try it in Chrome browser or Edge browser. It will, 99% it should work. Is that okay, Vicky? Okay, let's see the next question. Two sinusoidal plane waves of the same frequency, same intensity, traveling in the same direction, resultant intensity, where the waves meet with a phase difference of 0 radians. Direct formula based application question. Let's see if we can do this. The intensity of the resultant is given by I1 plus I2 plus 2 root I1 I2 into cos of del phi. This is the formula I will need because intensities of individual waves are given, phase difference is given, resultant waves intensity is asked. I1 is I0, I2 is 4 I0, and this will become 2 times of I0 into 4 times of I0 and cos of 0 degrees, correct? So this will become I0 plus 4 I0, and 4's root is 2, 2 2's are 4, so 4 into I naught square's root is again I naught, cos 0 is 1, 4 plus 4 8, 8 plus 1 is 9, so 9 I naught. Is 9 I naught there somewhere? Yes, option C. Okay, some of you made a mistake, looks like. That's the correct answer. Yes, Ramesh Babu, it is option C, 9 I naught. Let's go to standing waves, and then the last topic which will come is beats and Doppler effect. Are you guys ready? Full of Josh? Very good, Bhimashri. Excelente. Perfecto. Standing waves and organ pipes. What is a standing wave? When you have a normal wave, this is a traveling wave, you will see that the energy flows in one particular direction. But if you have two waves moving in the opposite direction, then together, when these two waves are basically added, two waves traveling in the opposite direction, what you get is nothing but a standing wave. This is how a standing wave looks like, where each particle just goes up and down like this. Okay, these are going to just go up and down. Okay, this is a standing wave, and in a standing wave you will see that the energy is basically trapped. Very, very important. Each of these things which you see, they are called as lobes, and some more interesting things over here. This one is called as a node. Nodes are those points which do not move, they are fixed. Okay, and the maximum displacement points, like the ones over here, they are called as antinodes. Very, very important. Also, one more thing, if you notice, one complete wave fits directly over here. So basically this is one wavelength. This is one wavelength. So one lobe will be half a wavelength. One lobe will be half a wavelength. Yes. Why not 0? Rupali, it's in reference with which question? Is it with the reference to this slide, some concept, or the previous one? Can you be more specific so that I can help you out, Rupali? Okay. Now, also remember, these particles go up and down together like this. So the entire standing wave looks like a skipping rope. All the particles go up, come down, go up, come down. And in the adjacent lobe, when these particles on the left side are going up, the particles on the right side will all be going down. So this will go down, this will go up, this will go down, that will go up. This will go up, that will go down. So it keeps going up and down, and in adjacent lobes they are exactly opposite to each other. All the particles in the same lobe move up and down simultaneously. Okay. Okay. So why not 1? What is 1? Why is it not 1? As in, like, what is not 1? This slide. Why not 0? What? I'm not sure. What should be 0, guys? Can you please elaborate? Okay. So if you can be more specific, Mr. Malak and Rupali, that will be better. Okay. And what is the equation of the standing wave? The equation of the standing wave is nothing but 2a. You can use sine or even cos, it doesn't matter, kx, and then you can also use again sine or cos, it doesn't really matter, into omega t. So why this 2a? Because this wave has amplitude a, that wave has amplitude a, together the max amplitude is 2a. So the amplitude of antinodes is basically 2a, and the amplitude of node is 0. Okay? Okay. Okay. Since the waves are opposite, oh, acha, why is it not becoming 0? Okay, so basically what is happening is, when two waves arrive together in the same direction, then they will interfere and they will produce a fixed interference. But imagine when two waves are in the opposite direction, then sometimes their crests will interfere, sometimes their troughs will interfere. So the pattern of interference keeps changing. Think about it. Sometimes the crests are coming, then that same crest will meet the trough. So destructive, constructive, destructive. So that's why the type of interference keeps changing. Okay, and that's why the energy gets trapped, because even if you simulate, if you watch my lecture which I had shown you in my nurture playlist, I had shown you the simulation. Watch that simulation. You will see two waves are coming in the opposite direction and they end up producing this pattern where some points always end up being fixed. They don't move, and the other points always end up moving, and some points have maximum motion. That's what happens. Okay? Okay, fair enough. Now, there are multiple ways of making standing waves, but what you have in JEE syllabus is standing waves via reflection or in organ pipes. So, three variations in that. Basically, when the string is fixed at both ends, basically closed organ pipes on both sides. That's the first thing, meaning you have a string which is fixed at both ends, or you have a pipe which is again closed at both ends. Then what you get is vibrations like this. This is one possibility. Okay, other possibility is like this. Other possibility is like this. So basically you get integral number of lobes, 1 lobe, 2 lobes, 3 lobes, n lobes. That's what you get, and the frequency that you get is basically NV by 2L. L is the length of the pipe or the string, V is the velocity of the wave on the string or sound, N is that number. Here N is basically 1, here N is 2, here N is basically 3. That's what you get. Okay, what is an organ pipe? Organ pipe is nothing but, see, when you take a string and you create a wave, the sound gets reflected from one of the ends, and you will see standing wave pattern on the string. Pipe is your normal pipe, like a trumpet or a piano. Even a piano has a pipe inside of it. So when you create a sound, that sound gets reflected within, and that's when you will see two waves traveling in the opposite direction. They also create a standing wave inside the pipe. So because organ instrument, mouth organ, so that name has come from your musical instruments, so that's why it is called as organ pipe. Okay, because it's a musical, it's used in musical instruments. Okay, great. And always remember, whenever it is fixed, you always get a node. Okay, keep this in mind. Very, very important. Whenever it is fixed, at that point you will always get a node, and wherever it is free or open, you will always get an anti-node. Keep this in mind. Fair enough, guys? Clear? Mangalam, I will let you know, bacha, very soon. Okay? Okay. Next thing, if it is fixed on one side and it is free on the other side, basically it is closed on one side and it is open on the other side, meaning something like this. It's fixed here and it is free over here, or it is closed here and it is open over here. Then the types of vibrations that are possible, the first vibration is something like this, where you have an antinode and a node, antinode. Second option is like this, and third option is like this. So many possibilities are there, and in those cases the frequency is always odd multiples of V by 4L. This is 4L, not 2L. That's the catch. Be careful about it. If you're wondering what the odd number is, here that odd number is 1. Here the odd number, obviously odd numbers have to be 1, 3, 5. Here the odd number is 5. Some books also write it as 2n plus 1, and then you get confused because some books write it as 2n minus 1, some books use 2n plus 1. If you use 2n plus 1, then n has to start with 0, and if you use 2n minus 1, then n has to start with 1. It becomes confusing. So I might as well write it as an odd number rather than putting 2n plus 1 or 2n minus 1. It's one and the same thing, guys. That's what I want you to realize. Okay, last thing over here is when you have free on both sides, when you have free end on both sides, is the same thing. Open, open, basically open, open on both sides. Then what you have is basically something like this. Okay, then you have basically antinodes on both the sides. You can also draw it like this, I believe. So here n is 1, here n is 2, and so on and so forth. And here the frequency will be NV by 2L, just like the first one. These are the frequencies which are possible. Based on this, you have two experimental setups which you must do. One is the Sonometer experiment, which is used to determine the unknown frequency of the tuning fork. It's based on fixed arrangement. And then you also have the resonance tube experiment. Go through it. It's there in your journals, practicals, and questions from that are also asked. Resonance tube experiment is used for determining the speed of sound, and sonometer is generally used to find the frequency of your tuning fork usually. Okay, keep this in mind. All right, cool. Moving on to some questions coming up on your screen. In the standing wave shown, the particles A and B have phase difference of how much? Sumit, at this point of time, you should give at least one, minimum one, if the portions are not yet completely done. But if you're at average preparation, then you should give at least 2. And if you are almost nearing completion, you should give 3 mock tests per week. All these figures are per week. Okay, bacha? Okay. Okay, come on, let's see if you can do this. A and B. First of all, do you realize that this is one lobe, this is another lobe? All the particles here will be going up like this. All of them will have different speeds, different displacements, because this is antinode, this is node. These points will be going down. These points, I told you, in adjacent lobes, the particles go exactly opposite. If these particles are going up, those particles will be going down. When these go up, these go down. So what's the phase difference? Obviously B, pi radians. Pi is out of phase. Correcto. Correct Ansh, correct Sumit. Moving on to the next question. The tension of a wire in some sonometer is increased by 0.25%. The resonant frequency when sounded with the tuning fork will. Meanwhile, I'll just draw the diagram for the sonometer, where you just have basically 2 fixed ends, and there is a pulley that is attached, on which there is a string, there is a mass. That's it. And here you get your standing wave pattern. And then you also have your tuning fork right over here, which is kept on that wooden box. The vibrations transfer and they oscillate the string, and you will see a standing wave pattern generated over here. So the question is, if the tension is increased somehow by pulling it or by adding more mass by 0.25%, then the frequency will change by how much percent? This is a killer question. Many students are going to make some mistake over here. Come on, figure this out. It's a very interesting question, my warriors. Think how much should be the percentage change in the resonant frequency with the tuning fork. Okay, is it 0.5% increase, decrease, or increase by 0.25%, or does it not change? Ansh is saying frequency will increase, but not sure whether it will be 0.5 or anything else. Remember one thing, if you increase the tension, if you change the tension, speed will change. And if you go by the formula NV by 2L, you will be concluding if V increases, F increases. Well, that is wrong completely. Reason being, when it resonates, the frequency of the standing wave has to match the frequency of the tuning fork. Correct? Only then it resonates. Only then it resonates. Have you changed the tuning fork? The fork is still the same. Tuning fork has a fixed frequency. That means the frequency of the wave also should remain the same. Then you will be like, sir, if V has increased, F should increase. How are you saying F should remain the same? You guys are missing something. That is N. In fact, N will decrease, frequency will not change to compensate for it. So you will see the number of loops formed here will be less because tension has increased, speed has increased to keep the frequency same. Why is frequency same? Because this frequency has to match. It's non-negotiable. It has to match the frequency of the tuning fork because that is the one which is powering the entire setup. Hence, the correct answer is it does not change. It's a beautiful question. A lot of students make mistake over here. Got it? There is no errors concept. There is nothing. It's just plain logic. Moving on to the next question coming up on your screen. Here yes, the answer is D. A wave of frequency 400 is sent along a string towards a fixed end. When the wave travels back after the reflection, a node is formed at a distance of 10 from the fixed end. Then the speed of the wave is how much? Okay, so first of all, the wave is getting reflected from the fixed end. So the moment you see that it is getting reflected from the fixed end always has a node. So let me draw a fixed end first. This is my fixed end, of course, and there is a standing waveform. So standing wave obviously has many lobes, like I have told you before. Okay, something like this. These are your lobes, and there is a node which is formed at a minimum distance. This is your node, and it has been formed at a distance of how many centimeters? 10 centimeters. Didn't I tell you some time back that this is one wavelength? This is one wavelength. That means the length of one lobe will be half the wavelength. If this is one wavelength, this is half the wavelength. Makes sense? So lambda should be 20 centimeters, which is nothing but 0.2 meters. What has been asked? What is the speed of the wave? What is wave speed? It is f into lambda. Do I know the frequency? Yes, it is 400. Do I know the wavelength? Yes, it is 0.2. 4 2s are 8, so 80 meters per second. Is that there somewhere? Yes, it is there. Option D. Option D. Correcto. Understood. Very good, Sumit. You got the right answer. Perfecto. 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 Moving on to the next question coming up on your screen, and here it is. Stationary wave is set up on a string fixed at both the ends. Distance between the two consecutive nodes is 18 at a particular mode of vibration, and then for the next mode, the same string, the distance between two nodes decreases to 16 centimeters. What do you think is the length of the string? Let's try to visualize this. There is a standing wave which is set up, distance between two nodes. So if this is a lobe, the distance between two nodes is given to be 18 centimeters. How many such loops or lobes are there? I don't know, but I will just just draw a hypothetical diagram like this. Okay, these are certain loops which are drawn. This is the length of the string. This is the length of the string. How many loops are there? Let's say n loops are there. Fair enough? N number of loops are there. Next time what happens? For a higher mode of vibration, the distance between two nodes reduces. So this loop size reduces. So if the loop size reduces, obviously there will be more number of loops. Correct? But it is clearly mentioned it is the next higher mode. So if this is n, this will be n plus 1, and the size of any one of them is basically 16 centimeters. That's what the question means. Nishi, I'll be doing one-shots, but not every day. There will be some days where I'll be doing mock tests, some days I will be doing just problem solving, some days I'll be doing most important questions, some days I'll be doing quick revision concepts. So different things, whatever I feel that will be important and will be very helpful for both 11th, 12th, even the dropper students. Okay, Nishi? All right. Now, here is the thing. Just write down simple geometrical equations. Like, if this is 18 and there are n in number, so the length obviously will be 18 into n. 18 into n will be the length. Similarly, for this one over here, 16 is the length of one loop. There are n plus 1 in number. So 16 into n plus 1 will be L, and we have to find the length of the string. So how about this? From the above equation, I will get n is equal to L by 18. Take that n and just put it over here and see what do you get. So this will become 16 into L by 18 plus 1 is equal to L. So expand it. So 16 L by 18 plus 16 is equal to L. So take it on the other side. So 16 will be equal to L common, 1 minus 16 by 18. So 16 will be equal to 18 minus 16 is basically 2. So 2 by 18. So this will become 8 times. So therefore L should become, check this out, 118 8s are 144 centimeters. Is that there? Option A? No, it is not B. It is 144. Option A. Correcto. So the catch of the problem was to realize that the next higher mode means if this is the nth mode or n loops are there, the next one will have n plus 1 because the next consecutive number for n is n plus 1. And the next thing over here was to realize it geometrically. There are n loops each of size 18. Here there are n plus 1 loops each of size 16. So just equate the lengths, you will get the answer. Yes, Jayavastri, definitely bacha. Obviously because theory is the same, right? Shall we go to the last concept of this chapter? So guys, the thing is, I'm so happy that all those of you who are attending or even watching it as recorded, you are completing 2 chapters in one short revision, and wherever you feel that you need additional input, make sure you watch my nurture playlist where I have covered each and every topic in detail. Okay, so that's something which you need to do. Alright, so beats and Doppler effect. So first of all, whenever you have 2 sounds of similar frequencies and they are sounded together, then you will hear maximum and then minimum and then maximum and then minimum sound. Sound will suddenly become loud, then faint, loud and faint. This phenomena is called as beats, and you will see from one maximum to another maximum, that is called as the beat period, and the beat frequency is obviously 1 by the beat period, and that comes out to be modulus of f1 minus f2, the difference of the 2 frequencies. That is your beat frequency. Okay. Yes, Ansh, if you're in 11th, you should be able to, because this is exclusively for 11th, but if you're a 12th or a dropper student, you can still watch it. Alright, excellent. Now, in conjunction with Doppler effect, you get amazing questions. So what is Doppler effect? Doppler effect is where the apparent frequency, apparent means the frequency which you hear, is different from the frequency of the actual sound because of the relative motion. So apparent frequency due to relative motion, and you always have something called as the source. It will have speed Vs, and you always have the detector who is also going to hear the sound, and he might also have some speed Vd. Then the apparent frequency is the original frequency into speed of sound. So if you are wondering what this C is, this C is speed of sound. This F0 is the actual frequency, and that turns out to be F0 C by C, plus minus. On the top you have Vd and bottom you have Vs. What is this? Why Vs below, and how to remember Vs is below and how to remember Vd is on the top? You can go multiple ways. One is alphabetically. D comes first, then S. So A, B, C, D, E, F, G. So D is first, S is later on. Or other way, source. Just think of sources below the detector. Just make a picture or a drawing and draw some source, somebody shouting or screaming, and the person who is listening is on the top. So that way you know that source is below and the listener is on the top. Okay, it is not my birthday, bacha. It is not. It's going to take a long time for my birthday. Okay, this plus minus depends on only one thing. If the relative separation reduces, if they are coming close, then always try to make this ratio which is there. Okay, this ratio which is there, try to make this ratio more than 1. Try to increase it. And if the relative separation is such that they are going far away, then that ratio which is there, try to make it less. That's it. When they come close, then make the ratio big. If they are going away, try to make it small. How to make a ratio big or small? Increase the numerator to increase the ratio, or decrease the denominator, then also the ratio increases. That's it. Okay, I hope this is clear. So the logic is never to remember any sign convention. That's the worst mistake which students do. Students try to remember if they are going far away, then it is plus minus. Now, try to remember if the ratio is increasing or is it decreasing. And how to remember whether it is increasing or decreasing? If they come close, it will increase. If they go far away, it will decrease. And everybody knows simple mathematics that when you have to increase the ratio, numerator can be increased or denominator can be squeezed. And when you have to decrease the ratio, numerator can be squeezed and denominator can be made big. That's all. Understood, my warriors? Clear about this? Very good. Excellent. Let's move to some questions coming up on your screen now. A train moves towards a stationary observer with a speed of this much. If now the train sounds a whistle with frequency f1, and if the train speed is reduced to 17, then the new frequency is f2. Speed of sound is given. What is the ratio of f1 by f2? Come on, let's do this. It's simple. See, you have a train, that means it's a source. It has some original frequency f0, and there is a person who is going to listen to it, and each time the train speed changes, the frequency heard is also different. So just use the formula. f1 will be original frequency, speed of sound, speed of sound. Only the source is moving, the train is sounding the whistle, and the train speed is there. Source is always below, detector is always on the top. So don't do anything on the top, only at the bottom. So the source will move, and the source is going closer to the detector. If it is going closer, relative distance is decreasing. That means frequency should be higher. If frequency is higher, make the ratio big. How do you make this ratio big? Will you put a plus sign here or will you put a minus sign over here? Will you put a plus sign? Come on. Will you put a plus sign over here or will you put a minus sign? Think about it. To make the ratio big, you have to squeeze the denominator. So put a minus sign. That's it. That's the answer. No, not a plus. If you put plus, denominator will become big. If denominator becomes big, ratio will become small. Then the frequency will reduce. We know that the frequency heard will be higher than f0 because they are coming closer. It's not plus, guys, it is minus. All right. Now, what will be f1 by f2? Because that's what has been asked. f0 cancels, c cancels. So it will be nothing but c minus vs1, and here it will be c minus vs2. C is given, c is nothing but 340 minus vs2 is 17, 340 minus 34. That's the first thing. So 340, yes, minus 17, that is 323, and over here that is basically 306. 323 and 306, just check this out. Is it coming out to be 19 by 18? Obviously it is not half, it will not be 2, it will not be 18. Yes, is it 19 by 18? Correcto, perfecto. Moving on to the next one. Let's see if you can get this question. Two trains, again they are moving opposite each other. They are facing opposite each other, parallel tracks. They can move with the same speed with respect to ground. Train A is the source. There are two cases or multiple cases where a person in the train B is going to listen to the sound. In which case will the frequency be the highest? Thank you, Nagaraj. All the best, Abhishek, for your physics exam. So two trains. This is train A. This is train B, parallel tracks. Train A is the source, so that is going to generate that sound. Here your detector is there. This is basically your source. Okay. Now think, the apparent frequency heard will be f0 c. Source is moving, so minus vs towards. Detector is at rest. Maybe, I don't know. This is one possibility. Source is moving. Another possibility, if the detector is moving, then it will be f0 c plus vs by c. Why plus in this case? Because you have to increase the ratio, so increase the numerator, obviously. You have to increase the ratio, right? So increase the numerator. That's it. Now, think. If A moves, if B moves, both are at rest, and if wind blows, which case will create the highest frequency? Think about it. Which case will create the highest frequency? In the first case, you are changing the denominator. This case, you are changing the numerator. I'll give a simple logic. Imagine you have a ratio like, I don't know, 4:3, example, 4:3. Or forget that. Imagine I just take C as It's like a number like 4. So if I write it as 4 by 4, where should I make the change so that I get a very large frequency? If I make the change in the denominator, like for example -1, this will become 4 by 3, which is nothing but 1.33. If I make a change in the numerator, if I increase it, this will become 5 by 4, which is 1.25. 1.33 is more than 1.25, so making a change in the denominator has a larger effect than making the change in the numerator. Same change. So hence, you have to make a change here. That means source should move. If source should move, then A moves towards B, then that will create highest frequency. If they are at rest, then the frequency will be still F0 only. If A and B are at rest, wind blows, obviously nothing happens. If wind blows, it will just reach earlier, but it will not change the frequency. It will still be F0. This will not be as much as this much. This will be the highest change. Correct, Aerox? So whenever you change the denominator, the changes are higher. Got it? Very good. A tuning fork of some frequency makes 5 beats per second with the string. If the beat frequency reduces, when the tension is increased, then what do you think is the frequency of that piano string? Beats related question. You have a tuning fork. You have a tuning fork which is having a frequency of 256 Hertz. The beat frequency is 5 beats per second. So I don't know, there are two options, because see, when I say beat frequency, it is modulus of F1 minus F2. It's mod. So the difference of the two is 5. Now I do not know whether the piano has 256 plus 5 meaning 261 or 256 minus 5 meaning 251 Hertz. I don't know that, because both the differences give me 5 Hertz. Okay, but there is something else given in the question. Oh, by the way, some options obviously get eliminated, like this one and this one. So either it is A or D. As per the question, if the tension of the piano string is increased, if you increase the tension, what will happen? The wave speed will increase. If wave speed will increase, what will happen? Frequency. The frequency will also increase, because F is equal to NV by 2L and V is root of T by mu. So that's why frequency will also increase. So imagine if I increase 261, if I increase 251, in which situation will the difference reduce? Because the new beat frequency is 2. If 261 becomes 262, the difference will increase. But if 251 becomes 252, 253, their difference will reduce. Hence, this is correct, this is wrong. Hence, you will get the answer as 251 Hertz. Got it, my bacha? Very good. It is 251, because if you make it 261, then the gap between them will increase. But here, 5 becomes 2, the gap reduces. The only way that can happen is 251 goes higher, then the gap between them reduces. Thank you guys for all the 100 likes. Thank you, Parthiv. Thank you so much. Option D, correcto. Moving on to one more similar question, but in a different way. Two forks are there, sounded simultaneously. They will produce 4 beats per second. Now, some tape is attached on the prong of fork 2, and they are sounded together. Then the beats are 6 beats per second. It was 4 before, now it has increased. The question is, what is the original frequency of fork number 2? Okay, let's try to think. If this is fork number 1, and it is given that the frequency of fork 1 is 200 Hertz. As per the initial situation, when they are sounded together, they give 4 beats per second. That means the other fork, if you take the difference as 4, can have 204 or even 196. Both give you a difference of 4 Hertz, because beat frequency is the difference of the two frequencies. Make sense? Now you have to choose whether it is 204 or 196. As per the given question, on the tuning fork labeled 2, you have attached some tape onto it. When you attach some tape onto it, what happens? The inertia increases, the mass increases. You are attaching some tape, it will have more resistance, it will find it difficult to oscillate. So if it was oscillating really fast, now the oscillation will become slow. So the frequency will reduce. So imagine both the cases, try to assume the frequency reduces here also and frequency reduces here. If you assume it as 204 and frequency reduces, the difference between them will also reduce. But as per the question, it becomes 6. The 4 becomes 6. How is it possible? 204, 200, difference was 4, difference reduces. But here, if 196 goes down and becomes 194, then the difference will increase. So obviously, this is wrong and this is correct. Hence, option D is the correct option. Got it, my warriors? Yes, it is. It is. Understood, my warriors? Perfecto. Do not forget that today's lecture notes along with all the formulas, along with the solutions, will be available in our official Telegram channel. You should also join it because all the important links, all the important notifications, timetable and every important detail including the notes are uploaded on our Telegram channel. Now, even if you're a 11th standard or a 12th or a dropper, or if you want to cover your entire syllabus in a short duration like crash course, all the options are available and all those things are going to be provided to you at a very affordable rate, and that's why I have put up all the links in the description box. You can check out all the courses, and if you feel like asking anything, please write to me on my Instagram handle, which is Shreyas_Vedantu, or you can leave a comment after the video. Everything can be accessed online. All the resources like assignments, notes, lectures, recordings, test series, all the question banks are available for all the kinds of students, be it 11th, be it 12th, be it dropper, for JEE 2022, for JEE 2023, and even JEE 2024. Alright, so that's it from my side. Yes, you can do advanced question, definitely. IT Jagdeep, you can leave your question, definitely. I'll definitely help you out. Hello Vandana, long time. Okay, kidding bacha. Okay, and I'll be doing some more questions even in the days to come, and lots of informative pieces coming up on this channel. So that's why do not forget to hit the like as well as the subscribe button. I hope you guys enjoy, and I hope you guys are now satisfied that I have done the major chapters of 11. I will do one more chapter which are like very important for the 11th to 12th moving batches. And yes, the mock test, sprint series, most important questions, PYQs, NTA Abhyas, all those things are going to continue on this channel, of course, in English medium. Thank you. Take care. Have a great time. Jagdeep, I'm not sure what was that question, bacha. If you can remind me which to follow for JEE 2022. I'm good at concepts but unable to apply. So if you are good at concepts but unable to apply, you should basically look at either DC Pandey, level 1 Tattva exercise, HC Verma objectives or initial exercise questions, including short answers, and then also make sure that you solve the mains type of questions first and then go to the advanced. Another important thing which will work in your favor, which I've seen many people transform, is watch the derivations or see the derivations for all the important formulas and theorems. Once you do the theorems, you get a very good understanding and you will see a sudden improvement in your application part. Another third tip I will give you for solving problems: always look at solved examples first and then try to do it out on your own. Beat the class problem, beat your book solved problems, try it on your own and by different ways. And then when you try to solve problems, don't go directly to or jump to a very difficult problem. Start with an average or substitution based problem and then slowly, gradually improve and scale up the level of difficulty. These are the things which I would suggest you. Okay, take care. Okay, so I hope, Vandana, that is also motivating for you too. And guys, I'm really banking on Vandana and all the others who are in 10th, because you'll be moving to the higher grades now. You have golden opportunity, 2 years. I don't want you to regret the days or the months to come, because there is a lot to achieve in the days to come. Because when you have a great beginning, you have a great start, you get that momentum and you gather that strength in the initial stages only, then you have no problems and you don't find it difficult after a few months where you have to think about backlogs and other problems, because you have certain regrets that, oh, I should have started in my 11th grade initially itself. So have a great beginning, have a great start. It's always good to start early and have a great start, of course. Okay, so if you feel like talking and if you feel like interacting, please let me know on in the comments, or you can contact me on my Instagram handle, Shreyas. Oops, my new Instagram handle is different, guys. I'm so sorry. My new Instagram handle is Captain. Oops, keep this. My new Instagram handle is Captain_Shreyas. I'll just put it up over here. Yeah. So for all the students, so it's Captain_Shreyas. So that's my Instagram handle. You can check me out over there. You can get in touch. I will try and respond to all your queries. Okay. Bye bye. Take care. Bless you, Joseph. Bye bye, Vandana. Bye bye, Nishi. Bye bye, Jagdeep. Bye bye, Ansh. Take care, Arox, Parthiv. Learn coding. Take care. Take care. Bacha log. Have a great time. See you again very soon. Hasta la vista. This was Captain Shreyas signing off.